Howdy folks, welcome to Calculus again. In this video, what we're going to talk about is a very kind of a simple concept that's called average value of a function. Okay? Now, you probably already know how to calculate the average of a bunch of numbers, right? So let's talk about that at first. You know, if you're given a bunch of numbers, let's say you're given the number 7 and 3 and 9 and another 3 and then maybe a 4, maybe another 7 and then maybe a 10 and then a 2. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8 numbers, right? Well, you already know probably how to find the average of a group of numbers, and that is to add up the numbers first, then divide by how many numbers there are. So 7 plus 3 is 10, 19, 22, 26, 33, 43, 44, 45. So this would be 45, and then there are 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the answer to this would be 45 over 8. That would be the average, which you could then calculate in a calculator. I'm sure I have one around here somewhere. So if you wanted the decimal number, you could just do 45 divided by 8 and get 5.625. 5.625. So the average value of all these numbers is 5.625. But that's the average of a group of numbers. Here's the thing about a function. See, a function is not just a limited group of numbers. A function is a relationship between two variables. So let's say that we had y is equal to 3x squared. We could draw a graph of 3x squared. It would probably look something like this. A parabola, right? With a vertex at 0, 3x squared. But here's the interesting thing about 3x squared. It has lots of values. It has -1 and 3. -1 and 3. So it has an output of 3. At 1, it has 1 and 3. So it's the same output, but at 1. Then it has an output at 2, which is 12. Has an output at 2, 12. But I want to remind you that there are an infinite number of values between 3 and 12 when the input is between 1 and 2. And there are an infinite number of values between the point -1, 3 and 1, 3. We put in all these infinite number of values. So if we wanted the average value of a function, the basic concept is to add, then divide, right? That's how we find an average. We add up a bunch of numbers, and then we divide by how many numbers there are. But that's when it's the average of a limited set of values. To find the average value of a function, we would have to add up an infinite number of values and then divide by what? Infinity? Well, that doesn't make any sense. So, in calculus, we have a very simple technique that allows us to calculate the average value of a function. And here's the idea. Let's say that we wanted to know the average value of this function on the limited interval. We have to have a limited interval to be able to find the average value of a function. What if we only wanted to know this function on the interval from 1 up to 4? From 1 to 4, on the closed interval from 1 to 4. Okay, well, the interval from 1 to 4 would look something like this. So we got this parabola, right? And let's say here's 1, and let's say 4 is all the way over here, from 1 up to 4. We have this strange shaped thing. And here's what's important for you to know, is that the way we would find the average value is basically by squashing down the high point and bringing up the low points to kind of a middle point. We're essentially going to create a rectangle out of this weird shaped region. And because basically what we're doing is we're finding the area of this region, and then we're going to divide the area by the base of the rectangle. We have the base and the height, and if we have this area, which is base times height, and if we divide it by the base, what we basically get, so if we divide the area by the base, what we basically get is just the height. And the height of this rectangle represents the average height of the overall function. And let me give you an analogy for that. If we have a function that does this, we have an infinite number of different heights. But if we push down all the high points and push up all the low points, what we're going to get is we're going to get a height that's in the middle, and that one height, a horizontal line, represents all of the heights of all of the points. Because this, basically when we started with, when we had 7 and 3 and 4 and 10, let's just do and 5. Let's add these up. 10, 20, 25, 29. 29 divided by 5 is almost 6, right? In fact, let's just make this. Now let's leave that a 5. We'll make this 4 a 5, make it a little bit easier. And that'll make it 30 divided by 5 is equal to 6. See, what's happening is this 7 is being pushed down, the 3 is being pushed up, the 5 is being pushed up, the 10 is being pushed down, and the 5 is being pushed up, so that all 5 of them are basically being a 6. And if we added them up, if this was a 6 instead, it'd be 6 plus 6 plus 6 plus 6 plus 6. That would be 30 divided by 5 is 6. So the idea of an average is to make all of the inputs, make all of the numbers in the set an equal number, an average, a mean. Okay? So here, if we push up these lower values and push down these higher values, push up these lower values, push down these higher values, and then push up all these values, the entire function would become a flat constant line, and it would be one number. There would be no x in it. There would be no variable. It would just be one number. That is the idea of the average value of a function. You're flattening the entire function out, bringing up the low values and bringing down the high values so that it's a flat line, and it's just a single value. Okay? Sorry, I just couldn't think of how else to say it. The concept of it is a lot more complicated than the procedure. So let me just get to the procedure and I'll show you how to calculate the average value of a function. All right, so the procedure for finding the average value of a function. We already said, what is the average value of 3x squared on the interval from 1 to 4. Okay? So if you want the average value of a function f of x on the interval from a to b, what you're going to do is you're going to do the definite integral of that function from a to b dx. So remember, definite integrals give us a finite value. The answer to a definite integral is a number. Then what you're going to do is you are going to multiply that definite integral by the reciprocal of the interval from a to b. So b minus a. So the formula is 1 over b minus a times the definite integral of f of x from a to b. So in this case, if we want to know the average value of 3x squared on the interval from 1 to 4, we're going to do 1 over, well, what's b? What's the end of the interval? It's 4. And what's the beginning of the interval? Minus a. A is 1. So it's going to be 1 over 4 minus 1 times the definite integral from 1 to 4 of the function. And what's the function in this case? 3x squared dx. 1 over 4 minus 1, that's 1/3. So I'm going to put a 1/3 here. Then I'm going to do my bracket. The antiderivative of 3x squared, power up. This becomes x to the third power. Then we're going to multiply by 1/3. 1/3 of 3 is 1. And so it's just x to the third power. Lower limit is 1. Upper limit is 4. And so this is now going to become 1/3 times. Plug the 4 in. 4 to the third power is 64. Minus, plug the 1 in. 1 to the third power is 1. 64 minus 1 is 63. Times 1/3 is 63 over 3. And the answer is 21. So the average value of 3x squared on the interval from 1 to 4 is 21. Okay? Let's try another example. All right, here's our formula. Let's put the formula in a box. And it says, what is the average value of cosine of x on the interval from 2 to 7? Okay, so it's going to be 1 over 7 minus 2. It's always 1 over this number minus this number times the definite integral from this at the bottom to this at the top, 2 to 7, of this function, cosine of x, dx. 7 minus 2 is 5, so this is 1/5. Then I'll put the bracket. Antiderivative of cosine of x is sine of x. Sine of x. From 2 up to 7. From 2 up to 7 is going to be, now I'm going to bring over the 1/5. Then I'm going to open a parenthesis. Now I'm going to put this stuff on the inside of the parenthesis. But I want a calculator for this. Now, you want to make sure that your calculator is in radian mode. This calculator is not in radian mode. In calculus, we deal in radians. So I want to hit this button, this mode button, and it allowed me to choose radians. Now that I'm in radians, I can do sine of 7. So sine of 7 is going to be 0.65698. Well, it's actually 0.657. So 0.657 minus, now I'm going to plug the 2 in, sine of 2 is 0.9093. 0.9093. And now, 0.657 minus 0.9093. Then I'm going to divide it by 5. And I get negative 0.0505. 0505. That is the average value of cosine of x on the interval from 2 to 7. Okay? Let's try another example. All right, this one says, what is the average value of 4 to the x power times the natural log of 4 on the interval from 2 to 6? All right, well, our formula says 1 over b minus a. So it's going to be 1 over 6 minus 2 times the definite integral from the a up to b, so from 2 up to 6, of the function 4 to the x power times the natural log of 4 dx. 1 over 6 minus 2, that's 1/4. So it's going to be 1/4 times, oops, I want to make that a bracket. Sorry. Let's make it a bracket. The antiderivative of 4 to the x power times the natural log of 4 is 4 to the x power from 2 up to 6. 2 up to 6. So now 1/4. Plug the 6 in first. 4 to the 6th power is 4,096 minus, plug the 2 in, 4 to the 2nd power, 4 squared is 16. 4,096 minus 16 is 4,080. 1/4 of 4,080, so over 4. 4,080 is 1,020. So the average value of this function on the interval from 2 to 6 is 1,020. Okay? Let's just do a couple more examples. All right, this one says, what is the average value of 7 over x on the interval from 5 to 14? Okay, well, we're going to do 1 over 14 minus 5 times the definite integral from 5 up to 14 of 7 over x dx. Okay, so this is going to be 14 minus 5, that's 9, so this is 1/9. And we'll do our bracket. Antiderivative of 1 over x is the natural log of the absolute value of x, right? And we have, this is 7 over x, so that's 7 times 1 over x. So this is going to be 7 times the natural log of the absolute value of x. Now, we don't really need these absolute values because we're plugging in positive 5 up to positive 14. 5 up to 14. And so now this is going to be equal to, we've got our 1/9 times, I'm going to plug this 14 into the natural log of x and multiply it by 7. So 7 times the natural log of 14. 7 times the natural log of 14 gives me 18.4734. 18.4734 minus, now we'll plug the 5 in, so 7 times the natural log of 5. Gives me 11.2661. 11.2661. Now I'll just key this in the calculator. Well, let me do this first. 18.4734 minus 11.2661. Enter. I get 7.2073 divided by 9. And I get 0.8008. 0.8008. This is the average value of 7 over x on the interval from 5 up to 14. Okay? Maybe let's do just one more example. All right, last one here we're going to do. What is the average value of the cubed root of x on the interval from 2 to 7? So, we're going to do 1 over 7 minus 2 times the definite integral from 2 up to 7 of the cubed root of x dx. Now, the cubed root of x, the antiderivative of the cubed root of x is the same thing as the antiderivative of x to the 1/3 power, right? And the antiderivative of x to the 1/3 power, we're going to add 1 to 1/3, and 1/3 plus 1/3 is x to the 4/3 power. Okay, because look, 1/3 plus 1 is the same thing as 1/3 plus 3 over 3. Common denominator, right? And that's going to be 4 over 3. Got to be good at those fractions to be able to do calculus. Now, we powered up, we added 1 to the power, but now we have to multiply by the reciprocal of the new power. The reciprocal of 4/3 is 3/4. So the antiderivative is 3/4 x to the 4/3 power. But I want to turn this back into a radical. So it's going to be 3/4 times, this is the root, this is the power inside of the radical. So it's x to the 4th power cube root. So it's cube root of x to the 4th power. This is the antiderivative of the cube root of x. So now 1 over 7 minus 2 is 1 over 5. So this is 1 over 5, bracket, 3/4 cube root of x to the 4th power, plug in from 2 up to 7. From 2 up to 7. So I'm going to bring over the 1/5, parenthesis. I got to plug a 7 into this. X to the 7, or excuse me, 7 to the 4th power, cube root. So I'm going to do the cube root. My calculator will do cube roots. Let's see, 3 cube root of x, 7 that is, to the 4th power. Oops. 7 to the 4th power and I get 13.3905. 13.3905 minus, now I got to plug the 2 in. So I'll do the cube root of x, or of 2 to the 4th power. So cube root of 2 to the 4th power gives me 2.5198. 2.5198. Now I'm going to do this number minus this number, and then I'm going to multiply it by 1/5 or divide by 5. So 13.3905 minus 2.5198, divide by 5, and I get 2.1741. 2.1741. That's the average value of this function on the interval from 2 to 7. Hopefully this was enough examples for you that we worked through. If you have to, go back to maybe the middle of this video and do these examples again. Have a calculator in front of you. Make sure that you're doing them right. Then work on all the examples that I gave you on the worksheet. Okay? But this is average value. It's a pretty easy to do. The concept may be a little difficult to wrap your mind around, but actually doing them is actually really easy. Okay? I'll see you in the next video.